So how can I have page 3 after page 4? Nobody knows, right? Or maybe I wrote 5. Good, so this is my page 6. Okay, so let's look at 53. So the average cost by definition is cost divided by X. So this is the title of the problem, average cost. Okay, so in dollars, okay, the cost of producing X belts is given by, and I copy C of X equals 750 plus 34X minus 0.068X squared. Find the rate at which the average cost is changing when 175, when X equals 175 units are produced. So they're not asking us to find the marginal cost, which is C prime. No, they're asking us to find the rate at which the average cost is changing when such and such happens. So this is what they want us to find, the average rate of change. So this is the average cost, but they want the rate of change of the average cost. So they want us to find C over X prime at 175. This is what they're asking us to find. The rate of change of the average cost when 175 are produced. So I can plug in because I don't have, first of all, I don't have this function, and then I don't have its derivative. So in step number 1, I have to find the function. I'm only given the cost. I'm not given this function. So C of X divided by X, 750 plus 34X minus 0.068X squared. Good. Can anyone tell us what to do next? What do you think?
You separate the numerator.
Brilliant. So in how many fractions?
3.
Exactly. So the first fraction will be 750 over X plus, can anyone give us the second fraction?
34.
Brilliant. Say it again.
34X over X.
Right. So we simplify that. Awesome. Minus, can anyone give us the last fraction?
Is it going to be 0.068X?
That's it. So now we do have the average cost. It's a piece of cake next to find its derivative. So let's find its derivative. C of X over X, which is this now, prime. Remember 1 over X. That's why I intentionally looked at it, because this appears all over the place. What is the derivative of 1 over X? 750 has to stay outside. But what is the derivative of 1 over X?
-1 over X squared.
Brilliant, thank you. What is the derivative of 34? What is the rate of change of a constant? How fast is 34 changing?
1.
0.
0 indeed. A constant prime is 0. So a constant prime is 0 and X prime is 1. They cannot be the same. If X prime is 1, the constant prime cannot be 1, and vice versa. If the constant is 0, X prime cannot be 0. Good. So now can anyone differentiate this last piece for us?
Is it just negative 0.068?
Brilliant. Thank you very much. That's it. Now, final answer. In this function that we determined initially, then in this new function that we just determined, and now we have to plug in 175. So C of 175 over 175 is 750 times 1 with minus 175 squared minus 0.068. Be very careful how you do this and how you put it in the graphing calculator because it makes a huge difference. So I have 750, put parentheses, minus, every time you start somewhere with this, it's not the operational symbol but the negative symbol, 1 over 175, you put square on it, close the parenthesis, and minus 0.068 and enter. So this is negative 0.0925. Okay, now we have to be very careful because we are determining a value of a rate of change, and this has to have 2 measurement units. Can anyone give us the measurement units, the 2 measurement units for this answer? And we have to write 2 measurement units. What is the measurement unit for cost? That's the y variable.
Could you go back to the problem so we could see?
Of course, yes. But cost, what can it be?
Dollars.
Awesome. Awesome. Good. So what was X?
Belts.
That's it. Dollar per belt. So we are going to say that the average cost in dollars per belt is decreasing by this amount when they manufacture 175 units. It's a negative rate, so it's decreasing. Any questions? Any questions? Do you think we need another word problem? We can look at population growth.
Yeah, can we do 61?
Yes, let's look at 61. Very good. I'm on page 7. So 61. Okay, so we are given P of t. Let's copy it. 75 plus 500t over 2t squared plus 9. The population P in thousands. Population. I'm taking notes. Population in thousands. Okay. Is given by this. Time is in years. Time in years. So then the rate of change of the population will have what measurement unit? If we need to determine P prime, what would be the measurement unit of P prime?
Thousands per year.
Of course. Awesome. Thousands of people, number of people, whatever, in thousands over, yes. Awesome. Good. So time is in years, and they are giving us the graph. Find the growth rate. What am I asked to find in part A if I'm asked to find the growth rate, which is the rate of change?
The derivative.
Absolutely. So I'm asked to find p prime of t. Excellent. So what is the derivative of 75?
It's 0.
Awesome, brilliant. Careful here. This fraction does only have one term in the numerator. I will rewrite this fraction like this. I can take the constant in front. This is the same thing with 500t over this because this is over 1. This makes a huge difference. Now if I have, don't change anything. If I have here plus 5, I cannot do that. And I will not. But because I only have one term, I would rather not involve that 500 in calculations because it will come out anyway at some point in time. So I'll keep 500. And this is my function 1. And this is my function 2. I have to differentiate as a quotient because it's a quotient. I have no choice. So when I differentiate as a quotient, the denominator is always squared. I don't have to do anything to it, but just square it. Now remember the sequence. 1 prime times 2 minus 1 times 2 prime. 1 prime. Can anyone give us the numerator prime? Yes, so times the denominator. Awesome. Minus. I copy the numerator. Can anyone differentiate the denominator for us so I can put it here? Excellent. Great job. Perfect. So now I have 500 stays out there waiting. 2t squared minus 4t squared. Negative 2t squared plus 9. Over 2t squared plus 9. These are not the same. You cannot simplify them. So 2t squared minus 4t squared is negative 2t squared and then plus 9. This is the rate of change, the function that gives the rate of change of that function. You know the drill. Everywhere where there is no corner, cusp, and so on and so forth, the function is differentiable. Awesome. Part B. Find the population after 2 years. What am I asked to do now? Population after 2 years. It's okay if you're wrong. How do I determine the population after 2 years? What do I need to do?
Do you plug in 2 for t?
Very good. In the population, not in the derivative. Right.
Correct.
Perfect. We'll determine that in a minute with the calculator. Part C. Find the growth rate at 2. What am I trying to do now? What is the question now? Where's my... What is the rate of growth or the growth rate at 2?
Plug into the derivative.
Awesome. So this is p prime of 2. We're going to put in the calculator and determine them in a minute. Good. Find the population after 12 years. What does this mean? Find the population after 12 years.
Plug 12 into the population.
Awesome. And final question. Find the growth rate at t equals 12. Anyone?
Put it in the derivative.
Yes. So I'm going to do this in y equals. I'm going to clear everything. I'm going to put the function 75 plus 500 in parentheses. Although it may work without, please make sure that you put enough parentheses so there is no discrepancy. 2t squared. The calculator will not know what you want. So plus 9 and close. So this is the function, 500t over 2t squared plus 9. And now I want to enter also the derivative, which is 500. Close, open the parenthesis for the numerator, negative 2t squared plus 9. Close, divide by, parentheses of course, 2t squared plus 9, close, and squared. So now I have both the function, the population, and the derivative. And I go to second and table, and I need to plug in 2, and I need to plug in 12. So here's the population, 133,824 people. I wouldn't, but anyway, so I'm going to write it. So 133,824, and then 12. Okay, 95,202. And now the rate of change, 2 years. So 1.730, which is 1730. And we're going to write the measurement unit in a moment. And negative 1.581 or negative 1581. So let's put the measurement units for all these. So what do you think? What is the measurement unit for P of 2 and P of 12?
Thousandths.
Yes. So this is what? We already changed that. We already did. So this is people, residents, people. Good. But what about these two?
People per year.
Yes, of course. 2 measurement units for the derivative always. Very good, thank you. Which means this is a positive rate, but after 12 years, this is a negative rate. Good. Okay, so I wanted to at least start 1.7. I'm on page 8, I think, yes. I know I'm looking at my phone, only my phone tells the time. I know I have only 5 minutes. So I'm just, you're not responsible for this section, 1.7. But I'd like to start it. Chain rule. The last rule of differentiation for now anyway. The chain rule. What does it mean? So we have a rule for sum and difference. Step by step. We have a rule for product. And we have a rule for quotient. We discussed all these. But now what is this? Well, this is a rule for a function that has another function inside it. So if you remember from college algebra, this is written f comp g, the composite of f and g. So if I have a function inside another function, I have to use the chain rule. I cannot use any of these. So let me give you a simple example. When we discussed x to the nth power prime, we said n in front, subtract 1 from the power. And today, I told you that we should have also written here at the end times x prime. This is the inner function, like this one. This is the inner, inside, inner. And this is the outer. This function is applied to the inner, outer. But the reason why we omitted this is because this was 1. We can no longer omit it. So here's an example. And then I'll write the formula. So if I have 2x squared plus 3x minus 1 to the 10th power, I'm not going to sit here and raise this to the 10th power. It will take me 3 days if I need to differentiate it, of course. You can say just expand it. No, 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 no. We have a very important rule that follows this pattern. Like before, we will bring 10 in front. We will subtract from the power, we will subtract 1. But this time, this is not, the derivative of this is not 1. Can anyone give us the derivative of that function? I don't have enough room. Please write it to the right. Don't write it like I am because I ran out of room. So can anyone give us the derivative of this function?
Is it 10? Oh, is it 4x plus 3?
That's it. Excellent. So then the formula is, if we have a function to the nth power and we need to differentiate it, can anyone follow this pattern and tell us the formula? Give it a shot. It's okay if you're wrong. As I said, you don't want to know how many times I was wrong. But I'm also double your age, so